Hello, Miss Linseisen. I'm going to be going over how to read motion graphs. This is in support of the motion graph notes page. So let's get started. Basically, graphs work the same way every graph works. On this graph, on these type of graphs, we're going to primarily be looking at, distance is on your y, and time is on your x. So we're going to be looking how the distance changes over a time period. So the first graph, the distance versus time graph, is going to show us the speed of an object. If we looked at a speed over time, this is going to show us the acceleration of an object. We're really going to be concentrating on these for this first assignment. Whoops. So remember that there are formulas that we've been using. Primarily, we've been using speed equals distance divided by time. That's what we're really focusing on today. So motion is a change in position measured by distance and time. So we know something is in motion if over time its distance has changed. The speed tells us a rate at which an object moves. We've looked at this a lot, so hopefully that's something that's not new for you. And velocity tells us the speed and the direction that an object is moving. Sorry, my pen's not working great today. We'll make it through though. And then acceleration tells us the rate of the speed or direction changes. So acceleration, remember, is just the rate at which the velocity changes. And velocity is going to be in a change in speed, direction, or both speed and direction. All right, time always goes on the x-axis. And because it's the independent variable, let me hope if I could spell, huh? It's the independent variable, sorry. The further to the right of the x-axis, the longer the time from the start. The higher up on the y-axis, the further from the start. So basically, this still is always going to be our distance. And this point right here, what is 0, 0, we're going to call that the reference point. It's typically the starting point. But when we say reference point, it's basically when we use a reference point, it allows us to see if something has moved or not. All right, so on your paper, I filled this out for you already just to make it easier. So on a horizontal line graph, a horizontal line on this type of graph means that the object is not moving. So what we see is that the distance, the way this line is, that the distance is staying the same, but the time is increasing. So if you think about it just logically, if the time is increasing but your distance isn't, it just means that you're stopped, that you're stationary, that you're not moving, that you're staying at the same position for some period of time. So if an object is moving at a constant speed, so constant, let me fill this out before. So constant speed, it means that it has the same increase in distance in a given time. So when you're looking at a data table, if the space between each data point stays the same, meaning that every second the distance increases 4 meters. That means that that object is moving at 4 meters per second. And that's what's going to create these straight lines. So in this situation, we've got something that's moving at a relatively fast speed. And we know that because it has a pretty good slope. And remember, the slope of the line is equal to the speed. and you calculate the slope the same way you always would, rise over run. So when we take the rise, you'll see that really it's distance, right? Because that's what the rise is. It shows us the distance from the starting point, that reference point, over time, which is the formula for speed. So the slope on a distance versus time graph, that is the speed that the object is going at. And when we have a straight line, we know it's going at a constant speed. So let's look at two moving objects. Both of the lines on the graph show that each object moved the same distance, right? So the distance being from here. But this one with the steeper slope has got a higher speed because it took it less time to go the same distance. So the steeper the slope, the higher the speed. The shallower the slope, the lower the speed. And because they're both straight lines, we know that it's a constant speed. So the opposite of a constant speed is going to be acceleration. So this part right here, where the line starts to curve, that means that the object is accelerating. That it's not, see right here, we have this straight line. That's a constant speed. 6 meters per second, whatever it is. But when it starts to curve, this part, really primarily this part right here, but it's still curving, that's going to be our acceleration. And here we have sort of a slow, this is kind of slowly going up. That means acceleration is slower. When it gets really steep like this, kind of like when the line is steep, we know that it's moving, it's accelerating at a higher rate. All right, so this little graph right here basically shows you everything you need to know about distance versus time graphs. It shows you what a steady speed looks like, meaning that it's a straight line. Stationary is a horizontal line. The time is changing, but the distance is not. When it's moving, it has a positive slope, it's moving away from the starting point. A negative slope, returning to the starting point. This is a fast, steady speed. This is accelerating. It's getting, the object is starting to move faster. All right. So that's pretty much it. These are the notes that are going to help you to answer the rest of the questions. All right. Thank you very much. Thanks for listening. Have a good day.